Hello friends and welcome back to Digitalk. So in the previous multiple sessions for the beginners, I have covered multiple topics of related with the AI agents where I explained with real life simple examples, okay, so that you can understand everything easily. So now specifically when we start building our own AI agent, okay, so we have a lot of frameworks for that one, okay. You don't need to build your agent from the scratch. We have a frameworks. You can use different frameworks according to your requirements for building the AI agents. Okay, so we have multiple frameworks like we have a LangChain and then LangGraph, Crew AI, AutoGen, Semantic Kernel. So there are multiple popular agentic AI frameworks are there. Okay, that you can use to build your own AI agents. Okay, so in this particular session, I am going to compare all the existing AI frameworks. Okay, with the important features. Okay, so that you should get an understanding. Okay, what is the benefit of each of these frameworks and which one is the popular, why it is popular, and which should I use when I am going to build my own AI agent. Okay, so let us small recap. So what we have learned about the agentic AI. Okay, so very first thing what we have learned about the LLM. Okay, so LLM can answer you. Okay, by looking up a existing model. Okay, in which it is trained. So there would be a humongous data which is available publicly, or you can say public data which is available on the internet. Okay, so your LLMs like the Chat GPT and Claude, Gemini, they all are trained in the humongous amount of data. And whenever you ask any question to the LLMs, okay, so you get a proper response of that one, right? So that is a very simple LLM call where you are asking some questions to your LLM and then you are getting a response based on the trained data. Okay, but agentic AI is completely different there, right? Because agentic AI is work on a particular goal. Okay, yeah, that means you ask for a certain goal to a particular AI agent. Okay, and it can execute that, and after finishing that task it will revert back with the result. It is not about a plain LLM calls, okay, where it is searching for some predefined model data and then returning the response. So it does that dynamically work for you by calling different tools, okay, and then once the result is completed, then it get the response back to you. So that means an agentic AI system can think, plan, and use tools and take multiple steps in own to reach a goal, checking its own work along the way. Right. So this we have covered in detail in very basic way in the multiple previous sessions, how AI agents work, how it, what is the use of tools, right? So overall, what we say that when we talk about the AI agent, okay, it work in a loop, like it think, it act, and then it observe. So it go like this one. It repeat until your goal is reached. Right. For example, if I say book me the cheapest flights to Delhi next week. Okay. So now here what I'm asking my agent, book me the cheapest flight. So very first thing I need to book a flight. It should be the cheapest, and for Delhi and then for next week. Okay, so here you can see there are multiple subtasks in this particular requirement. I need to book a flight which should be cheapest. That means there would be a multiple flight service providers. So you have to look for the cheapest one, and you have to look for the location Delhi, and this is for the next week, right? So an agent search flights, compare prices, check your calendar, and books all by itself in several steps. So what we are doing here, it's not like a simple LLM code that just like we interact with the Chat GPT, Claude, or Gemini, right? So we are giving a goal oriented task, and then your agent execute all these tasks for you, and then it give you the result back, right? So what we are doing here, like we are if you are going to book a flight, okay, you need to contact the service providers. Okay, your agent should know about your payment details. Okay, and then it should have access to the this travel agency's website access with the help of some APIs, okay, where it can look up for the prices and it can book the flight for you. It deduct the money from your account, and then once it is booked, it will send you the booked flight PDF or ticket on your email. Okay, so this agent is doing some goal-oriented task for you. This is the main difference what we see in the agentic AI. Now, when you are going to build the AI agent, okay, you don't need to do everything from the scratch. Okay, we have the multiple frameworks that we just download. Okay, and we start building our agents. Okay, so that means there would be a lot of tools that need to be integrated for your AI agent to work. Okay, and for integration of the tool, you may have a different kind of a plugins. That plugins will be available in the frameworks. It is just like the simple yeah, a framework that we use for the development of application. If we have some development experience, then we have a multiple development frameworks are available in the market, right? You can download and start building your Java code, C++ code, Python code. We have a multiple frameworks. Similarly, when you are going to build your AI agent, so we have a corresponding multiple AI agent frameworks that you can download and start building your applications. Okay, AI agent applications. You don't need to start writing a particular AI agent code from the scratch. Right. So the very first framework is the LangChain. This is most of the popular toolkit for building LLM powered apps as of today. Okay. So what is it? So LangChain give you ready-made pieces, prompt, memory, tools, and connectors to your own data that you can chain together to build an app. It is the has the biggest ecosystem and community of an agent framework. The very first thing, it is has a biggest ecosystem and community of an agent frameworks, right? And then what is saying here, it is a ready to use pieces of prompt, memory, tools, and connectors to your own data. So that means, suppose that you are going to build an AI agent for your itself, okay, and you want your AI agent to has a reachability to your own personal data, maybe your organizational data, okay, so that your employees or maybe the authorized persons can ask some queries about your organization policies, and then your chatbot, which is having an integration with the LLM, okay, can give the response based on your personal data, right? Because simple LLM cannot respond to your organizational queries, because your LLM doesn't have access to your organizational data, right? So for example, if you are asking your LLM, okay, this is your LLM, it could be your chat GPT, it could be your Claude, it could be your Gemini, okay, you're asking some questions, okay, so your LLM look for the already trained humongous data, and then it generate the response for you, but this data is publicly available data, right? Now if you say that, if you're saying that what is my organizational leave policies, your LLM will not able to answer that, right? Because your LLM doesn't have access to your organizational data. It is personal to your organization, right? Similarly, if you will say what is the grade I have secured in my higher secondary, your LLM will not able to answer, because that is your personal data and it is available with you only, right? So in that case, what we do, we build some AI agent using some existing prompt, memory, tools, and connectors, okay, and we give access to our own data, and then your AI agent can respond to your personal questions. It is similar like you think a box of ready-made building blocks for AI. You simply connect the blocks, and instead of building everything from scratch, right? So that means it is just like a building blocks. We take the blocks and then we make a building. Okay. So similarly, you have some already built blocks are there in your line chain. Okay, and you can simply put together and you can build your own AI agent. Okay, so that means, simple example, you upload your company's PDF and build a chatbot that answer employee question by first searching those PDF, okay, then writing an answer using only what it found. This pattern is called the RAG. So this is called the RAG, but we have learned earlier as well, right? Retrieval augmented generation. So if suppose that we need the integration with our personal data, our personal organizational data, so your LLM here not going to work. So what you need, we need the RAG in between, retrieval augmented generation. Okay, so once we have a RAG, then your LLM with the help of RAG can contact your organizational or your own personal data, and then it can answer. Okay, this is a simple example which is specifically related to the LangChain here. So simple, it is a building block. We have a different kind of blocks are available. You can just take the different blocks according to your requirement. Okay, and then you can build your AI agent within a short period of a time. Second is the Lang graph. So Lang graph is again is built by the LangChain team. Some same team which has built the LangChain. Okay, they have built the Lang graph as well for agent with complex branching logic. So here, the Lang graph is, you can say it for a bit complex AI agents or complex workflows. Okay, so with that means with complex branching and logic. So what is it? Lang graph models an agent workflow as a graph. Okay, so what we do when we design the different agent AI agents in the Lang graph. Okay, so we create it as a graph. Okay, so each step is node and arrows decide what happens next. This give you explicit control over loops, retries, and branching paths, something plain chain struggle with. Like, so for example, we write some different programs, right, in the Java, C, C++. Okay, then in the programs we have a loop as well. So what we do with the loop, it repeat itself until certain condition met, right? So there would be a certain program which is a simple program where we do not have any loops, okay, or there would be some programs where we are using loops to repeating itself, right, to achieve a particular goal. So similarly here, when we create the graph, AI agent graph, okay, or we create the AI agent in the Lang graph, okay, so here what we have a blocks, and then we can connect them with each other like this one. Okay, so by connecting this, what is happening here, So we can have a more control over here. Like suppose that there are step 1, 2, 3, 4. If third is not achieved, it can go back to first. If second is not achieved, it can go back to first. If fourth is not achieved, it can go back to 3 or maybe to 2, or it can be go back to 1. So that means we have a more control over with the help of this lang graph, okay, where we have a multiple steps that we are designing in an AI agent. Okay, and each and every step has like an independent and they can repeat itself. So you can think it like a flow chart for your AI brain. Instead of straight line of steps, the agent can loop back, branch based on conditions, or pause and wait, just like flow chart or on a whiteboard. So just like we create a different flow charts, right? We have a flow charts methods, right? So similarly, we have the lang graph where we can create the AI agent with the help of graph. So we can connect the different component with the help of arrows, okay, and then we have a complete control over the AI agent flow. So we can go from any step to any step, okay, based on the links that we create between the different blocks. So you can consider with a simple example, a customer support agent check an order status, and if information is missing, it loop back to ask the customer to clarifying question, repeat until the issue is resolved instead of giving up after one try. So suppose that you are asking some question to your customer support agent, okay, and then it's not like that you have given some question and you have got the response of that. Okay, you may be interacting where some of the information may be missing. Your AI agent needs some more information to give you the proper response to check for the database. It may go back to you and it will ask you the questions, it will clarify that questions, and again it can go for the repetition. So this is we can achieve with the help of lang graph. So where we can connect the different blocks, okay, with the help of arrows, and then we have a more control over that. So it is on top of your lang chain, and it is used to build some bit complex AI agents, or where you need the branching logic. Then we have a crew AI. So this is built of a specialized AI agent that collaborate. This is the main functionality or feature of this crew AI. So what it is? Crew AI let you define a crew of agent with each own role, goal and expertise that work together on a shared task, much like assembling a project team, but with a very simple beginner friendly setup. Okay, so now suppose that what we have been learning so far, AI agent work on the goal based task. You have given some goal and start working on that. So there could be a one AI agent, there could be multiple AI agents, okay, for fast processing. Each one is doing in parallel, right? So this crew AI agent is something like this one, multi-agent, where we have a crew of agents, each with its own role, goal, and expertise. So each AI agent will have own expertise, okay, and whenever there is a work that has been assigned, okay, so that particular work or task or goal is given in a split or in a sub task to the different members of that particular group, okay, but with a very simple beginner friendly setup. So think it like hiring a small project team, one researcher, one writer, one editor, each does their own part, then handle off their work to the next person, right? So they have a dependency on each other. So maybe they are working on independently on some task. Okay, but at the end you need to give result back to the client as a single result, right? So they are interacting with each other, but as an independent agents, they have their own expertise and they are working on them specific tasks, right? Simple example, to write a blog post, a researcher agent gather fact on a topic, a writer agent draft the article from those facts, and an editor agent polish the final draft before it published. So this is the crew AI, which work on the specialized agent that collaborate. They are collaborating with each other. Now we have AutoGen. So AutoGen is a framework from the Microsoft for multi-agent conversation. So again, on top of the Crew AI, okay, so we have an AutoGen from the Microsoft AI, which is again build or work on the multi-agent system. So what it is lets multiple agents and humans can as well. If you want then the interaction of humans as well at some places in the multi-agent system, you can have that as well. Okay, if needed, talk to each other in conversation to solve a task together. It is especially popular for coding and problem solving tasks that benefit from back and forth review. Okay, so that means you have a certain kind of a task which is very complex and where it is not going to solve in a single flow. There would be lot of back and forth between the output and the inputs, okay, when it is executing, right? So in that case, for you can use this AutoGen multi-agent system. So you can think it like a group chat of AI expert debating a problem. One propose an answer, another challenge or improve it until the group agree on a solution, right? So there would be a multiple agents, okay, and whenever a result is given by a particular agent, it is cross checked by each and every other agent as well, okay, and majority of agent has to agree on the result that has been given by a particular agent, okay. It is good to take forward, right? That means we have four agents, they are working independently on a task T1, T2, T3 and T4. Now suppose that T1 has given you the output, okay. Now this all three agents are going to verify this output if it is good or not, and out of three, the majority of the agent, example, out of three at least two has to give the agreement on this output, this is good, okay, or they may debate on itself as well, okay. This can, like, the output can be improved, it is good or not, so they can have a debate and then they can do it until a satisfies result is achieved. Simple example, a coder agent write a Python script, then a critic agent run and review it, pointing out some bugs. They both go back and forth automatically until the code passes all the tests. So this is the autogen. Now we have semantic kernel, which is a Microsoft SDK for adding AI to existing business applications. So SDK is system development kit. Yes, okay. So this is a very generic term that we use for development of the different applications, which can be developed in any language. Okay. So this semantic kernel is like a plugin, and what this plugin does, so in your organization you may have a multiple applications, you can say it is a legacy application, or maybe it can be built on some latest programming languages or software, like maybe you have some code which is written in the Python, some in Java, C plus .NET, right? So that means your organization is working traditionally on the multiple applications, but now they want to adapt for the AI, okay. They want to implement the AI and AI agents in their traditional applications. So in that case, you don't need to change your code. Okay, like if you are going to now integrate your applications with the agentic system, so it's not like that you have to change your code. You just need a plugins, okay, and you can plug in that in your existing applications for the AI features or AI agent features. Okay, so what is it? Semantic kernel is an SDK available in C Sharp, Python, and Java for plug-in AI skills and planners into your existing softwares. So enterprise can add AI feature without retrying their whole code base. So you don't need to change any code. Okay, there would be some small retrofits may be required in your code for the integration. Okay, but overall you don't need to change your code for this one. Okay, so you have your own organizational enterprise code or enterprise softwares. So you just need to have a plugin from here, which is called the semantic kernel, and then you can build your AI agent functionalities in your existing application. So think of it like a universal power adapter. It let AI plug straight into your enterprise system you already have instead of forcing you to replace them. So that means you don't need to replace your existing application if you're going to adapt the AI systems. So a company add an AI assistant to existing .NET inventory system. This assistant can call the company's internal API directly to check stock level or place reorders when asked in plain English. So that means you have a .NET framework, .NET applications for the inventory management. So you can integrate your this .NET based inventory system with using the plugins, semantic kernel plugins with your AI applications. Okay, and then you can use the functionalities of the AI agent or agentic AI in your existing enterprise applications. Now the next one is OpenAI Agents SDK. So this particular SDK is just like the semantic kernel, okay? Not semantic kernel, but a similar way of semantic kernel, right? Semantic kernel, as I said, is a plugin for the integration, but this OpenAI Agents SDK is to build a agents, but which we can consider as a lightweight agents. Okay, it's not very complex, which has a multiple workflows and then multiple branches. Okay, it's a lightweight. If you want to build some your own lightweight agent, okay, which is be production ready agent frameworks, where you need some production ready agent framework, so you can go with the OpenAI agent SDKs. So this is a minimal official SDK from the OpenAI for building agents with tools, build in tracing, debugging, and clean handoff between agent. It is a simple path if you have already building an OpenAI model. So you can try starting with the OpenAI agent SDK as well. Okay, so the official starter kit straight from the manufacturer, like from the OpenAI, fewer part to assemble, and everything is guaranteed to fit together. So as a beginner, like if you are planning to have an career in the this AI agentic AI or AI agent, okay, then you can start with the OpenAI agent SDKs. Okay, and like a travel booking agent handle a flight searches, but when a customer asks about a refund, it hand the conversation off to the dedicated refund agent that specialize in that particular task. Okay, so this definition looks like similar to the other frameworks that we have learned. Okay, but it does all these things in a simpler way. Okay, this is bit lightweight and simpler. Okay, but that is specifically for the beginners, and if you go for a production ready application, then you have to opt for some different frameworks. Then we have a Pydantic AI. This is a type-safe Python framework focused on reliable structure output. Now, what does it mean? Built by the team of behind Pydantic, this framework forces an agent input and output to match defined structure, a schema. If the AI answer doesn't fit the expected shape, it caught automatically. So, what does it mean? Let us understand with this one. A straight grammar and spell checker on your AI answers, it wouldn't let a reply through unless it exactly the format you expect. Okay, that means again it is similar kind of a things, but again whenever you ask any question or whenever you assign any goal to a particular AI agent, okay, then it has to go through from a different phases. And when it is going to the different phases where you are giving some input and it is generating some output, okay, so there would be a certain structure will be created by the Pydantic AI. For each and every output and input, there would be a specific data structure is created. And if the AI answer doesn't fit the expected shape, it caught automatically. So then again, it check for the structure. And then based on the structure, it identify that the result it is expected or not. Okay, it is good or not. If it is not, it automatically catch that particular exception. Okay, and then it start again generating the particular response based on the requirements. So simple explanation: an agent read a scanned invoices and must return the vendor's name, date, and total as a structured record. So here what we are doing, we are scanning an invoice with the help of AI agent, and it has to return the vendor's name, date, and total. So this will have a specific structure in the output and even in the input as well, what is required. Right. So Pydantic AI guarantees the output always matches the exact structure or flag an error. So it has to return the exact information or the structure that has been requested by the user. Okay, so this kind of things we can develop with the help of Pydantic AI. So overall comparison, LangChain is general LLM apps which can use RAG. LangGraph is a for complex and branching workflows. Crew AI role-based agent teams. AutoGen multi-agent conversations. Semantic kernel, it is for like a plugin for integration in your enterprise business applications. OpenAI agent SDK is a lightweight production agent. Pydantic AI is a type-safe structured output. Right. So what we have learned from the discussion, what kind of a question this can be addressed this session, which framework best fit a use case you have in mind and why? Do you actually need multiple agents or would a single AI agent, well-designed agent can do your job? How would you keep an autonomous agent reliable, safe and without budget in production? Which trade-off matters more for your team, fastest to build or easy to control? So these kind of a questions we can address with the help of the discussion that we have done so far in this particular session. Thank you.